Hello everyone, my name is Vitaly Honchar and I am senior software engineer. This is my new video series about software development, during which I will develop my new open source project and record each step on the YouTube video. I am doing YouTube video recording without any editing, so enjoy my video because you will see how really software engineer works. In this video, I will go through my new project FlowRun, which is uh, open source project to run AI workflows, and requirements to it. I define it in this blog post, which will be available in the link to description of YouTube video. And right now I will jump to the system design. I already described some things for myself yesterday in morning, and in today we will continue. So let me just recap. Let's check what we have. We have this high-level design. Let me move it here. And let's go. So we have high-level design. We have user which sends request to our application server. We are not developing application server. This is client to my project FlowRun. And this application server executes AI flow in FlowRun, and FlowRun runs some prompts, workflows, agents, anything which interacts with LLM. Main feature of FlowRun is reliable. LLM runs flows, tasks, and so on. Ahead of time, prompt developer developed these prompts and deployed it to FlowRun. And we are going to design this FlowRun service. So let's see detailed design. So we have FlowRun. It executes when we execute in Flow, we are saving data execution in the database, and next synchronously FlowRun starts communication with LLM. The key we will use here transactional outbox pattern to reliable communicate with LLM. But before we will go to design this FlowRun service, I want to think about abstractions used in this FlowRun, because to do good design, to understand what's going on in the FlowRun. So, in fact, what we have? In fact, we have service which performs some actions with LLM. This service may be will be able to perform one prompt, to execute one prompt. For example, analyze information about company and summarize to me for one prompt. But also the service will be able to execute a chain of prompts. For example, analyze something, next retrieve information from it, and third prompt to summarize me something. So it's chain of prompts. And third operation which it can execute is agent. So it may be some chain of different tasks. So do one thing, do second thing, and finally we will want to execute AI agent to do some research and finally execute another action. It's pretty similar of how long chain graphs works. So it's in fact like long chain graphs, but completely different, because we are going to do declarative creation of this graph and infrastructure as code sim. So do not develop these tasks in Python or any other programming language. It will be a language-agnostic approach. Define it in YAML file, like Kubernetes YAML file, so like Terraform, especially them inspired me to do this project. So let's start from the simplest abstraction which we have in this project is a task. Task, it can be LLM, execution of LLM prompt. So let me just put here as an example to have better understanding what we want to achieve. Let's do this. I already have some prompts. find it. One moment. Let me open Visual Studio Code. Actually, there is one service which I developed in the past. It's AI Founder. No. Let me find it here. And I have already predefined prompt. With them it will be simpler to understand what kind of prompts we are going to execute. So this project is also open sourced and is available on my GitHub profile. Let me find prompt. So here we have prompt. For example, HVV is pretty big prompt, but we don't care about content of it. We need only prompt. So let me put here this prompt. So it's our prompt, pretty big prompt, and this is what we will have when we will develop real AI applications. Prompt will be big. So we have here prompt which depicts this execution LLM prompt. Also, task may be not related to prompt. For example, send email, because so this. Oh, sorry, you somehow. Okay. So here is a prompt. Somehow Visual Studio Code didn't close. Second type of task is send email, because I don't want to bind only to LLM tasks, because this flow engine should be pretty flexible and allow people to execute their tasks, for example, written in another programming language, which is pretty structured tasks without any LLM inside it. At least for me, when I did AI Founder and I think about this project, it was what I need at that time. So that's why task will have two types: one LLM task, second not LLM task. And also, after having task, we want to define these tasks in some chain. So we want to execute these tasks in some graph one by one to understand, to build more complex flows. So let's say task flow and how it will looks like. Let's go here. So we will have task 1, task 2, maybe even not like this, because it's hard to express this information when we are doing from right to left. It's better to go from top to bottom in this case, because I want to write something about task. So it's something like this: task 1, task 2, task 3, and let's say end. Let's put another color for end. Today is morning, it's 7:39, so I'm recording this video and working before my work. I hope you will enjoy my videos, because I will do it frequently. So let's go. So first task, what can be? It can be this. Sorry, what did you say? Execute LLM prompt task. Let's say LLM task for simplicity. Okay. Let's mark it another color. Second task can be again execute LLM task. So we are building here a chain of tasks or a graph of tasks. But I will not use here naming as graph, because it's too technical name graph, it's pretty clear for software engineers what is this graph, but from business in terms of view or another marketing people, graphs is pretty complex to understand. That's why I will have a name for this graph as flow. So I will name it flow. It's a flow of tasks. Flow because we are executing one task, second, third, and so on. So I will name it flow and don't name a graph, but in fact it's a graph. It's a graph and these tasks are nodes in the graph and connections between them are edges. But anyway, it's flow and let's go. So what we have? LLM task and send email task. So I can imagine this flow. We are doing some analysis, executing analysis one by one, and finally we are sending email with the notifications and analysis was completed. And let's define task flow with agent. In fact, it will be pretty similar. Maybe even let's do this LLM task and say here AI agent, because task is pretty good abstraction and we can implement anything inside task. That's why let's say that this task 2 will be AI agent. So first is LLM task to summarize user request, for example. Second is AI agent, which is doing some complex actions or performs research. And third is non-LLM task, which is sent email. Okay, sounds good. And let's add here AI agent as implementation of task. So, in fact, first version of my flow run will support only execute LLM prompt task, but I want to understand what I want to achieve. That's why I am depicting here different all possible tasks which I will go to support in the final version of my service. Otherwise, my software won't be developed in the right way. So I want first to put in the system design my target architecture and target state which I want to achieve. And next, when I will implement it by versions, so by milestones, where I will deliver features incrementally with incrementally increasing complexity of the system, like agile thing. So let's go next. We have task flow. What else we need? Okay, we need also, so here is data schema for the database which I created yesterday. We have here task, it will be name, type can be this type, execute LLM task, let's name it LLM task, send email task, AI agent task. Actually, this send email is just an example. I don't think that it even will be included in the first version. So type is enum. This is data. What we will put here? I will not add type values here in the diagram because it will be hard to understand this diagram. So task data, yes, task can have parameters. Parameters is input parameters for a task with which task should be executed. Almost all tasks will have parameters because you want to specify some data to task before executing it. Next we'll have this will be JSON column data with embedded field which will refer to the model. Model will be some Anthropic model like Cloud Sonnet or OpenAI model or DeepSeek model, any model which our system are going to support. And provider, it will be LLM provider company, Anthropic, OpenAI, OpenRouter, anywhere, anything. And our flow definition, as I mentioned, flow is a graph. We will have nodes in the flow, where node will be task and edges in the flow, which will connect tasks with each other, or nodes with each other. One thing is not clear for me here is that while we have this flow, we have these tasks. So task is simplest abstraction, smallest abstraction used in our system. But let's imagine situation of our clients of the service. So who are our clients? Our clients are two user personas. First is prompt developer. Second is application developer. Application developer is our client. It's our client from application server, like on this diagram. So application developer works on this application server, and prompt developer develops prompts itself and creates these flows itself. The problem is that this service should be used in some organization, some company, maybe some small, maybe some big company, where different teams will work on different projects. And in current data schema design, we can have situation when, for example, let's say, let's imagine that company who will be client of our service used it to implement PR. Let's change font here. GitHub PR review flow. So GitHub PR review flow was defined by, let's say, core team in the company, and the same flow can be defined by DevOps team in the company. GitHub PR review flow. And in current data schema design, we have a conflict because we are relying on the name of the flow to be unique attribute, and then them should choose different names. This is not very convenient because at the end, all our teams in the company will see all defined flows in the system. It's super inconvenient. And even more, it's security risks, because maybe you don't want to allow marketing team to see how PR review flow executes, or otherwise you don't want developers team to see what marketing team is doing with their flows. That's why we need to think here about multi-tenancy for our system, or how to protect our access control list. We need to implement some access control list. We need to implement some account supports in this system. But I don't want to implement enterprise level ASL in this system from the day one, because I have too much work to do on another parts of the system. So I want to do development in the incremental way, instead of promise do everything from the day one and do not deliver anything, because I will be overwhelmed with features to develop. That's why let's think how we can create a flexible architecture which will allow us in the future add this access control list feature, add this multi-account support, and maybe even don't do it right now, or do it with very light mode. So what we can do here, first thing about which I can think is what we if we will do group the most simplest one is this. Let's say we will store account information in our system and we will have account ID. We will have account ID on both abstractions. I can't make it bigger. Okay. Strange. I can do it. Some bug in Obsidian. Let's say here task, and let's put here what is this? Why? Oh, finally. Okay, so we will put here account. No, look, I can't change size of this, and understand why I can change size of this item. It's really some bug in Obsidian. So I can change size of this one, but not size of this one. Maybe I should close and reopen this Excel draw diagram. Yeah, let's go here. Okay, finally it works. Okay, let's see next. So we have account ID here, account ID here. LLM task data will be embedded into the data column in task. Also we have model and provider. So if we want to go to create task and flows account specific structures, I think we should do the same for model and provider, because I can imagine that marketing team, for example, can use more sophisticated model to perform some complex research, but for developer teams it should be allowed to use only more cheaper model because of frequency of execution analysis. That's why I think we need to put here, I think we should put here account ID. Let's do it like this. So yeah, it's pretty simple thing. We just added account ID, but which will refer to the account. So it will have ID, name, and description. For example, core developer team, and description for what account this was used. And with this I will put only this relation here because I don't want to make my diagram super complex. To read, I will add in the description that account ID refers to the account. Okay, so it sounds good for me. Let's think more what we can do. I will delete this one, we don't need it. So we are going to execute this task. It will be account specific. Okay, let's finish this part of system design, and after that we will jump to the DSL design. So how we will have execution of our tasks. Let's group this logically in the diagram to see everything from beginning to increasing of its complexity. Let me put system design here because the detailed design, because it doesn't make sense without understanding of data schema. And let's think. Actually, no, before we go, let's improve our system design a little bit. Colors in system design are important because with colors you can highlight people attention in different way, and always use colors in your system designs. So let me improve my... You see something bad with this Excel draw in Obsidian, but I will not change it because actually I like design with this Excel draw. So it's pretty good product actually, even with bugs. I think it's even not Excel draw, it's maybe plugin in Obsidian, but it's really nice because I can do my system design or draw some diagrams in the Obsidian and write text in the Obsidian. I love this approach. Pretty good plugin. So okay, it's much more better right now. We just have a separation between columns and tables. So what is the time? It's almost 8 a.m. I probably will need to finish my recording because I need to go to prepare for my job. But let's do very quickly one thing. So we have detailed design. So we have, first of all, we have here a couple of use cases. First use case is to create flow. Second use case is to execute flow. Right now it's execute flow. Execute flow. Let's put it here because we can't execute flow without flow creation. Let's say create flow, and let's put actor who will create this flow. It will be this prompt developer. Create flow. He will create flow from not from raw HTTP request, but from YAML file. That's why let me put here file icon, YAML, make it small, just to show that we are going to use here YAML file in the create flow. Create flow is not very interesting. Flow, what we will do, we will parse YAML file and save flow in the database in convenient structure to handle by the code, and that's it. YAML file use it only for convenient reading by humans. After creation of flow, what we are going to do? We are going to execute our flow. Application developer will execute our flow. execute our flow and how it will be executed. So application developer sent a request to execute flow. We are saving execution. We are not executing it instantly because we want to provide reliability that this flow will be executed. Actually, we can start executing instantly to reduce latency between creation of flow and execution of flow. Probably we are going to do this to minimize latency. So we are going to execute flow instantly, but we also will save flow in the database to retry it. And what we are going to do, we are going to create retry flow execution. As far as we are writing integration with LLM, which is completely unreliable, even OpenRouter can solve this. We want to have retries in our execution. So we will have here scheduler, which is going to check executions every 1 second. It's pretty low timeout to minimize latency for executions, but it's really not matters too much because our LLM execution will take 30-60 seconds, so this latency in 1 second is not big deal because we don't have a real-time system here. Here we have batch processing system which will provide our result sometimes. It's simple transactional outbox pattern. When our developer will send execute flow command to flow run, we are going to save execution in the database. Next, we are going to execute instantly this flow and increment our execution to 1, and flow will be executed. Our this retry function will not work because we will have here condition use execute flows only if timeout of last updated date is more than 60 seconds or 90 seconds, because LM flow can be executed not instantly. LM flow can take a lot of time to execute. That's why we need to put big enough timeout for flows which we want to pick up and retry. Do not start retrying flow execution while in parallel execution is in progress. And finally, we need to show how application developer will get results. Get flow results. No LLM here. So first, get flow results. Let's put database here. Get flow results. So we simply, what we'll do, we are reading flow results from the database, and if on the previous step to execute flow execution was successful or failed with error which can be retried, we will write to the database flow result. In case if it's successful flow result, we will write to the database success result, and developer will use it to continue application flow. In case if it's not retriable error, we will write error to the database and developer will get error result and handle it on the application server side. I think that's it for today. So it's it's finished system design for service itself. It's scalable design. So okay, before I'll finish, 2 minutes and let's go about for scaling for this system. I wrote how to scale this flow run a couple of days ago, and next I will finish video. So how we can scale a flow run? It's a stateless service. We can scale it in the ASG, for example, just deploy to more instances in AWS, or in Hetzner launch more machines, and we will scale our service itself. It can handle bigger traffic, handle more amount of flows, but the problem is here our database is a bottleneck here in this approach, and our LLM is a bottleneck here, because our database is still one, and in this approach we will just overload database. Actually, this approach can work pretty well if we have high traffic, and we can optimize our database for this, and even big traffic can be served on database if database optimization was done correctly. But as far as we can't infinitely optimize database, and some point of time we will not be able to scale like this, and database will be our bottleneck. So second approach is to use database sharding and deploy multiple database master instances, and route our requests to different database instances, to different shards, and database will not longer bottleneck in our scaling approaches, because different flow run instances will use different database instances depending on the sharding key, but LLM will still be a bottleneck, because LLM vendors will charge you too much money for overusing a LLM API, or just throw you rate limit error. That's why to scale LLM vendors, one of approach is which is in the gray zone, and it's not pretty ethical approach, is to create different LLM accounts for LLM vendors and use them. Or second approach is to use different LLM vendors. So for one flow, use, for example, Gemini, for another OpenAI, for third Anthropic, but this scaling is for really huge lot. It will cost a lot of money, but anyway, scaling costs money. So I want to show that this service can be scaled and even serve huge traffic. Exact numbers can be provided only with load tests, but from the ideological terms of view, it's scalable service. So, okay, thank you very much for your attention. In next video, I will continue doing system design for this flow run service, and I will show you how to write system design, because system design is not only to create diagrams, but also to write it in that way that people will be able to read it. So okay, thank you, bye, see you in next video.